Hey there. I feel like my camera is out of place. Are you? No, I guess that is. Did I change the. Nope, let's not mess with it. I'm going to screw it up. So let's just move this over. I'm probably just not sitting center. Oh, yeah, my camera's off to the side. What's up with that? Let's fix that. Okay. Let's see. Am I way too loud? No, I'm okay. And I am actually live. That's good. That's good. So hey everyone, it's been a while, but there's been more important things in the world going on. So didn't seem right to stream, but I've been working on some stuff and it seemed like I should hop on the stream at some point. So I hope everyone out there is doing okay. Hope everyone's taking care of each other. But yeah, I'm not nearly eloquent enough to say more than that right now. So go support the people around you. They deserve it. But yeah, I'm gonna bring you up to speed with what I've been working on the last couple days. I think it's actually been a while since I streamed. I think probably the last time I streamed was for the BlackBerry keyboard stuff, and I've been quietly working on some other stuff. Let me go tweet about something real quick. Just telling people that I'm going live now. Okay, so what I've been working on. Should probably make a README for this anyway. So, give me 1 second. That's not what I wanted. Shift 4. That's still not what I wanted. So one of these days I'll figure out a tiling window manager. I will absolutely, one of these days, figure it out. What am I looking for? I need to add folder to project. Perp, perp, perp. Five. Okay, so yeah, I've been working on what I've been calling home fleet. Because I have a weird. What is. Hi, Shirshak. Screen res is too low. Well, my little laptop can't handle streaming more than 1440p. So you get 1440p even though this monitor is 4K. So these are the things that I do. The bar down at the bottom is a i3 bar. So it's this is how much space is on my main hard drive. This is my home IP address, at least the internal one. This is my battery charge percent. My laptop's like 2 years old now, so it only charges up to 72% now. PC load, it's the time. Don't really need. Oh, I do need VLC open, don't I? Don't need Zoom open. Maybe I can save some PC cycles. Yeah. So what I've been working on a fleet of devices for my home network. So I got a couple things that I want my home network, and it's if you watch my old streams like Internet of Streams, this is actually interestingly enough exactly the project that Internet of Streams was supposed to be, but now I've finally gotten around to make it. But the idea is to make a home network of devices, not connected to Wi-Fi or anything like that. All of devices that I've written the software for in Rust. So the first one that's going to come up is going to be a plant light. So if you follow me on Twitter, you see I have a bunch of like shelves that I added grow lights for plants on, because I don't have that. Like my apartment's kind of on the middle floor kind of thing, so I don't get a ton of sunlight during the day, so plants aren't very happy inside unless they're very low light plants. But I yeah, got some lights, so I can have whole shelves of plants, some for my living room, so I get fresh air, and some for the kitchen, so I got spices and stuff like that. I tweeted some picture of a poorly drawn shelf at some point. But yeah, I've been building this on top of the awesome ESB crate from Talus. If Talus is watching, thank you again. This has been awesome. But I also didn't want people to be able to control the lights in my house. So I felt it was important that I have encryption or authentication of some sort. So I went out, and Tony Arcieri, or really the Rust crypto organization as a whole, have put together a really cool crate called Cha-Cha 20 Poly 1305, which is an all-in-one cryptography and authentication thing. So I've basically been building a layer on top of that. So let me zoom out a little bit. So what I'm gonna have my PC acting as a bridge to the PAN of my own devices. I'll have a bunch of devices. I've got my kitchen plant light controller. I'll have my living room plant light controller. I'll probably have that little like BlackBerry PDA thing. I'm not going to roll crypto. I promise. I'm just dropping in someone else's crypto, and I trust Tony Arcieri way more to do crypto. You should not trust cryptography done by me. Yeah. The network is, so the it's not really like the lowest level is basically enhanced shock burst. It's such a sweet name. Shock burst. Then Cha-Cha 8 Poly 1305 for authenticated crypto. So Cha-Cha 20 is an algorithm for doing, it's a crypto primitive. You can use it for hashing or signing or encrypting. It's meant to be like a really simple crypto primitive that doesn't require a lot of processing power. And there's even a version called Cha-Cha 8, which is a reduced round version of that, in that it's useful. Basically, they did a paper that said, like, we chose 20 rounds because it seemed like a good idea at the time. And then since then, they've come back and been like, well, Cha-Cha 8's probably good for, like, everyone, except for, like, you know, if you're handling really sensitive, crazy stuff. But I'm not. I basically just need people snooping around my neighborhood to not be able to turn on my plant lights. And so Cha-Cha 8's probably going to be fine for me. At some point, I'll probably, in the future, replace with, what is it? AES 128. The good one, I can't remember which variant, but the not terrible one, because there's some acceleration for that on the NRF hardware, which means it'll be faster. But for right now, I did some benchmarking. Today, it's like max of 200 microseconds to encrypt, decrypt a 250 byte message. So, you know, if I was trying to do this in real time at like the max speed of the network, it would probably not be great. But 200 microseconds is short enough for me, because I'm probably going to be sending one message like a second or something like that. So, like SHA. What's the AES GCM Civ is the version. Not like SHA. Yeah. But yeah. Well, SHA is a crypto primitive, but it's not a particularly great one, in that SHA-1 is not generally very secure. But I guess if I use SHA-512. But I'm not going to do that on my little microcontroller. But I'm falling off the rails already. So basically, what I have is I've set up this folder, CD office hours, home fleet. Let's do BR. Okay, so this is the directory that I have going on. Loki's guessing, but no, the answer is AES 128 GCM Civ is what I'm doing. or what I will probably plan to switch to. I think right now the Rust Crypto is doing a release of a bunch of crates. Once that's done, I'll probably switch over and implement hardware accelerated versions of that. But yeah, not today. That's a yak that I don't need to shave today. So I've basically broken up so I've got this project called Homefleet. This is on GitHub. I'll put a link to it somewhere. But it's jamesmunn/Homefleet. And there's 3 main folders. There's embedded, and this is where all the microcontroller firmware is going to go. Today I'm working with an NRF52832. I'm for the actual production one, I'm going to switch to an NRF52840 just because I have these little NRF52 dongles, which are like little $5 or $10 NRF52s on a stick. So I'm going to use that instead of my somewhat more expensive Decawave boards. But these ones are easy to work with, and the 52 and the 840 are almost exactly the same in practice. So we're going to use that. I'm going to use the 52 832 for now, and then eventually switch to the 840. But yeah, that's where all the embedded firmware is going to go. I've got Gateway, which is going to be the application that's running on my computer, that's going to be talking to the radio. And I've got Shared, which is code which is shared between the PC side and the microcontroller side. In the embedded side, I have a couple applications already. I have 2 applications. I've got PlantLight, which is going to be the actual firmware that controls the relays. So the lights that I have are just LEDs that are behind relays. So it's really just controlling 4 GPIOs to toggle the relays on and off. But that's going to be the PlantLight. I'm going to have 2 of these in my house. I also have a PC modem firmware, which is going to be the microcontroller that's sitting on, it's going to be plugged into USB of the PC, and it's basically just going to provide an interface so that some application on my computer can talk on this Shockburst network. It's basically just going to be exactly a modem. It's going to translate from like probably some commands that are given by the PC and then just send them to the network and receive packets from the network and give them up to the PC to process. I want to say, if you've taken the Ferris embedded trainings before, this is a really similar setup that I did for the that radio draw exercise we did for the embedded trainings for Oxidizer. If Ferris is given a training at your work or something like that. This is just an architecture that works and has code that I'm going to go steal from myself and copy and paste. I also have this other crate, which is actually a library crate called Fleet ESB. This is where I've done my wrapping of cryptography, and I'm going to put some protocol stuff here. Yeah, right now there's limitations where the network will only support 7 devices. Well, a central device and then 7 microcontroller devices, which is enough for me for now. Eventually, I'll probably make a more complicated middle layer that handles like non-hardware addressing or something like that. Or maybe I won't. I don't know. Yeah, well, let's take a quick look at Fleet ESB. So essentially there's 2 sides. There's the PRX and the PTX. So in Shockburst terms, we've got PRX and PTX, which is primarily receiving. We've got primarily transmitting. And this is usually a PC. And this is usually a microcontroller. So the way it works is you have PRX, which is just listening. It generally doesn't initiate any communication. The PTX, whenever it feels like, sends a packet, and the PRX, all it can do is respond as part of a response to an incoming message. So basically, the microcontroller will shout out, say, hey, here's this message, and then in the response, or the ACK, the PRX can also provide a payload. And this works so that you can have microcontrollers that are normally sleepy, like they're not actually listening all the time because they're battery powered and their radios are off. But they can wake up, send a message, immediately get a response, and then go back to sleep. So it's good for low power devices. Shockburst was like mostly used for keyboard and mice, as far as I know. Like it's not meant to be a simple, or it's meant to be a simple protocol, and not build a lot on top of it. But hey, we had a driver for it, so I'm going to use that. And I don't need... the other limitation is you can only have packets up to 252 bytes, which could be a limitation, but not for me. I'll get around it. Most of the messages I'm sending are probably going to be like 5 bytes, like turn on now, so not a whole lot going on. So it works pretty well for me. And it's encrypted and everything like that. So, well, now it's encrypted, but yeah, so PTX is really just there's a lot going on here. I'm not going to go over it today. I want to actually write some code today and not go over it. But basically, like, I've got 2 main interfaces, whether you're a PRX or a PTX. You can send data, where you can give it some kind of outgoing type and which pipe to send it on. It does all of the magic for you. Like, it sets up a radio packet. It serializes the packet directly into the buffer, so it's 0 copy. Like, it serializes directly into the outgoing buffer. It sets up all the encryption. Sets up a nonce. Nonce is used, like the nonce that I use has like a timestamp and a rolling packet number so that you can't replay packets and stuff like that. So it encrypts it, adds the nonce to the payload, sends it over the radio. When you're receiving, it reads the packet from the radio, checks that the nonce is good, which is basically a signature, updates the tracking variables to make sure that it doesn't accept stale packets, decrypts it. If it decrypted okay, then we deserialize the message, so we deserialize it to a Rust struct. So basically, over the radio, it's kind of like you're just sending Rust structs and receiving Rust structs, and the library entirely handles cryptography and serialization and everything for you. So it's just like, it's almost like a channel in Rust, but the channel is over a radio link from your microcontroller to a PC. At least that's the model that I'm going for. PRX side is almost exactly the same. It just does a little bit different stuff, but it still handles all of the cryptography for you. Yeah. Did I not? Burp, burp, burp. There was one thing that I probably didn't do, and I've got some dead code. I can get rid of that. On receiving, no, I do have the... Okay, yeah, you receive an RX message. I needed to put the metadata in there, so it doesn't just give you a type back. It gives you the type and the metadata that came with it. Stuff like what pipe did this come in on, and yeah, stuff like that. Stuff that I'm not going to get into, but I have cryptography, so that is a thing. So let's see where I left off. So Yateki was saying, don't show embarrassing ProBAR-S bugs. Actually, I've been nothing but pleased with ProBAR-S and Cargo Embed. I'm still running a version that I kind of manually cobbled together, but that's okay. But I can do stuff like CD embedded plant light and CD office hours fleet embedded PC modem. I got 2 of these boards. I got 2 of these Decawave boards. And Cargo Embed lets me do this cool thing where for each of them, I can tell it what the USB ID and then the serial number of each of the probes are in there. And it just always flashes that specific device. So when I go in and plug both my devices in, let me plug this in up here. I'm running cables. Hopefully this cable is long enough. I need to get more USB hubs. Yeah, Yateki is saying that there's new versions out. I just haven't updated yet, and I probably won't. So Yateki, you have to suffer through the knowledge that this is built off a very handcrafted, patched version. It's essentially built off what I submitted the PR for. But I can do something like Cargo Embed Release. Actually, I don't want to start with the plant light. I want to start with the PC modem. Cargo Embed Release. And it's going to rebuild so it's going to go ahead and it's going to flash my device for me. and it's already listening because this is the same firmware that's probably on there. And as I flash it, these messages will probably stop. So now my radio is sleeping because it didn't hear anything. This is my receiver and this is the transmitter. So now you can see that they're having a conversation. And at first it was unhappy because the nonce was wrong because it was initialized with the wrong cryptography stuff. But this is essentially my two devices talking to each other wirelessly with encryption, sending totally deserialized. So you can see this one is going to say sent general initialized session. This one's going to say got general initialized session. And then this one is saying and then this one sends general ping. And this one got general ping. So they're basically just loop back, or not even loop back. They're just call and response. And if I hold one of these devices in reset, It's interesting that this doesn't reset the device. Wonder if... I don't know why the reset button isn't working. But if I unplug one of these devices, this one stops because it's freaked out because it's not talking anymore. And this one's just sending without receiving. But yeah, basically I have the ability to specify two devices and I just work. And if I had like 3 or 4 devices, I could have them all talking at exactly the same time, which is amazing because this is a huge pain in the butt to set up with OpenOCD or JLink GDB or whatever. So huge shout out to everyone working on ProbeRS and Cargo Embed because it's literally the best ever. And this is all using all those prints you saw were using the RTT crate. So I don't even need a serial port wired up. What am I doing now? I have them talking. I was going to go write the firmware for my relay thing. So I just need like a super simple little state machine basically that's just like making sure that let's see what I have in here. That's Fleet ESP. I'm not going to work with PC modem right now. So what do I got in here? I got some stuff. A lot of this is still like I copied and pasted the radio examples. Ooh, yeah, here's my cryptography key. So now you can come around my house and decrypt my messages, but it's a pretty unoriginal cryptography key. Yeah, I need to come up with a way to like have an environment variable in a build.rs script or something like that that changes this, because otherwise I'm just checking in my cryptography keys into Git, and that's not good. But rest assured, this will not be the key that I'm using for my actual deployment. What do I need to do? I need to... let's see, plant light. I need to control relays. Make sure relays don't toggle too often. Make sure relays go out if we lose comms to server, just so like if my server shuts down, my lights don't stay on for 24/7, which would be bad and my plants would probably die. I need to manage comms. Periodically ask for incoming messages. Drain outgoing queue. What else do I need to do? I don't think I need to do much else. I need to control the... My solder job is gross on this. I think that's really it. I need to have like running timer for comms and relays. Trying to think. This is a pretty simple device. I don't think it needs to do anything. Yeah, I don't think it needs to do anything. I wrote some relay controlling code. I apparently haven't committed it yet. But yeah, just some like states on off, 4 different relays, some kind of I wrote some blind code. So tell you what, let's wire this up to the LEDs. So what I'm gonna do is I'm going to go down over here. Clean up PDF. What is this called? This is called the DWM dev schematic and module schematic. Because I need to figure out what my LEDs are. So let's see. I'm going to use the LEDs first. So LEDs. Do these have 9, 12, 11, 10? 9, 12, 11, 10. Let's see, this is 9. Yeah, that is 9, 12. 9, 12, 11, 10. So that's top to bottom. So 9 is GPIO 30. I'm just looking, I'm like following the pins on the microcontroller so I can figure out in software what this needs to be. 9, 12. 12 is 14. 9, 12, 11, GPIO 22. And 10 is GPIO 31. And I really shouldn't be doing this because there's the DWM 1001 crate, and this has already been solved. But does this have a little table that tells me helpfully what pins are what? No, it sure doesn't. So now I need to go look at the module schematic. I don't know why you default to this zoom level. DW1000, that's not what I want. I want the primary core MCU. So GPIO, please tell me you have consistent naming for this. Where is the footprint for the DWM? Oh, you are not going to be pleasant. GPIO 30 is pin 10. GPIO 14 is pin 7. 22 is pin 8. And GPIO 31 is pin 9. And if we come over here and we look at the P, it's going to be J1. Here we go. Yeah, let's make sure this makes sense. P7. So 1, 2, 3, 4, 5, 6, 7. GPIO 14 pin 7. Yes, you are. So I'm going to be looking for P1 dot, or excuse me, J1 dot, J1 dot 10, which is P0 dot 30. J1.7, which is P0 dot 14. Pin 8, going to be P0 22. And pin 9 is pin 0 dot 31. Nope. Okay, so this should hopefully be all I need for this. So let's go to my main. So I need the pins. Let's just make my relays struct. So relays T, where T is rolling timer. Do I have a fake timer in here already? I do have a fake timer in here. Fake clock. Input rolling timer for fake clock. Wonderful. Let me get away with this. Do I have mod relays? Yeah. Use relays. Relays. So you're going to be a fake clock. Relays is going to be a relays with a fake clock. Fake clock is just this thing that I have that, like, every time you get the current tick, it just increments the number. And it's because I was too lazy to set up an actual timer, but I will set up a timer at some point. But for now, just incrementing the clock by 1 every time seems to be reasonable. So I need to take the pins. Set up LEDs. And what do I need? Do I actually have like a pin structure, or is it just from pins? Excuse me. So I need to give it an array of pins. Pins, and I need to give it an array of what is it? Contacts dot device dot context device. No, right. P0. So everything's in P0 already. Okay, so P0 dot, what do I need to give it? I need to give it P0 dot P030, P0 dot P014, P0 dot P022, P0 dot P031, and then let's give it a fake clock. And into open drain output. Open drain config. What do you mean by open drain config? Hello, please take me to this type. No. Disconnect 0, standard high drive. Standard 0, disconnect 1. What did I do for that before? High drive 1. Okay, I feel like I need to open up the 832. This is just the errata. Why do I only have the errata? 832. Dear datasheet. What do you open drain? I don't know why it does this. Really? What is the... High drive 0, disconnect 1, usually used for wired and connections. Standard 0, high drive 1. Isn't 1 supposed to be in an open drain? Isn't that just supposed to be... let's just give it standard 0, standard 1 for now. That's not even an option. S0, S1. What? Doesn't even really need to be open drain, does it? See, I guess some of these pins have different... Why do we only cover 4 of the... Why do we only cover 4 of the variants? How is this not non-exhaustive? What is going on? Am I in the right field? Do not all of the pins have the same thing? I guess they don't call it open drain, is it? I guess open drain is only these configurations. Interesting. Ah. Well, I think it needs to be pulled down. These are active low LEDs. Yes. So let's just do high drive 0, disconnect 1. So this is what? This is in GPIO. So main use HAL GPIO level open drain config. High drive 0, disconnect 1, and we want this to be level high to start with. So that's my 4 LEDs. Struct relays is private. Well, let's fix that. Mismatch type. Ah, right. Missing relays. Wow. Use relays. Relays. Did I not hit save on relays? Ah, relays. Cool. So now I've got relays. Let's just make like a little binary counter on it, I guess. What does my interface for relays look like? Oh, it's gonna complain because Well, what I'm going to do for now is just, in a totally bad way, make a... Yeah, let's just make sure our GPIOs are working before I do anything else. GPIO test. If counter and OB 1 equals 0. Relays. Relays dot GP, what is relays GPIO dot set low. Let's just shamelessly copy and paste this 4 times and make this 10, make this 10, and make this 10. And of course, I need to use my embedded HAL traits. Let's see which one of these boards starts blinking so I can tell which one's which. That's this one. So let me unwind this. So you can see I've got little, I can't see my camera. I've got little walking LEDs. Is this pattern right? Yep, sure looks like a binary counter to me. Okay, so that's good enough for... What I'm actually going to do is I'm going to switch these boards because I would actually like you to be over here. And it won't matter because Cargo Embed is smart enough to keep the right devices. So you go live up here because you're going to be the modem, and I'm not going to look at you most of the time, although this is going to be wrong because this one has the pins soldered to it, and I want to control my my stuff with those pins because that one doesn't have a pin header soldered to it. Okay, so now let's undo all of this terribleness because I have, in fact, validated this works. Save you. Relays, let's make you not pub anymore because you really have no business being public. I know what some of these words mean. Yeah, Olympio, you're right. The thing that confused me is those are the configs for all of the GPIO modes, where actually the Open Drain config is smart enough that it only picked the ones that are relevant to Open Drain. So yeah, they're for non-Open Drain mode. Yeah. So what do I need now? I really should make a real timer. I tell you what, I'm going to take a quick 5-minute break, and then I'm going to come back, and I'm going to wire up an actual timer. Maybe actually from the RTC, because I have that, and that seems like a reasonable timer to use for counting real time. So, yeah, I'm going to take a quick break, and I'll be back in like 5 minutes. Okay, so I tried to build the docks while I was taking a break, getting more sparkling water. Sadly, not sparkling enough. I don't know. We got a new machine, and sometimes it just doesn't, like, it seems to spit air out, but doesn't actually sparkle the water. Sad. I like sparkly water. Okay. So what was I gonna do? I was gonna cargo dock open. It has. Where have you opened my docks? It's probably very helpfully on another. Hello, please, cargo dock open. Hello, hello. Where are you, docks? Office hours, home fleet, embedded, target, dock. Where's like index.html? Where's my docs? Target doc. There's supposed to be like a document for. Where's the hidden? There's one document, car doc, document, private items, open, please, maybe? I don't know why you're not opening. What am I going to do without my docs? Is it because I'm in a workspace and is it confused? Because that's pretty lame. Oh, that will open one. Let's tear this off and move you to 5. Okay, I don't know why it's. Now it's got everything. Weird. What am I looking for? I'm looking for the RTC because I have an RTC. I think actually on NRF HAL. I think there's actually. Do we not have. I thought I had an example for this. Oh well, guess I don't. So I guess we're going to do ticks with RTC ticks. Access to the NVIC is not provided. The interrupt must also be enabled there. Manual call NVIC through the use of RTFM. Okay. Well, let's go ahead and make a version of the get counter. 24 bits of range. So if I have 24 bits of range, I just want to see how often this rolls over. So 2 to the 24th divided by 32,768, 512. Really? It's gonna tick that often? Which means that I get a rollover every 8.5 minutes. Well, that's actually less cool than I necessarily wanted. Let's see, that's at 32. I wanted something sort of millisecond-y. I guess I could divide by or I could just have an event that increments a timer. I guess that's probably what I'll do. Yeah, that's probably what I'll do. I'll probably just have a um hmm yeah, where's my fake timer? That's in main. So let's I probably have a pub struct struct RTC timer, which is probably gonna include a probably doesn't actually need to include the it's probably gonna be an atomic. Yeah, I think it's just gonna hold ref or time is gonna be a reference to atomic U32. B. Self dot time fetch add one ordering release. And then from main, I'm going to steal. Where's my fake time? Ordering acquire. Should be called by the RTC interrupt. Because now if we 768 by 60 divided by 60 divided by 24. So like every day and a half we get a rollover, which is probably fine for what we're doing. where did I actually get that from? Use Fleet ESB rolling timer. For so now I'm going to get rid of this fake clock and fake time. Static RTC store. Get rid of you. And then instead of fake timer, I'm going to do one 159. Cool. So now it's driven by the rolling RTC timer. It does mean that I need to timer. Let's have a pub const ticks per second, which is a U32 equals 32,768. And then in relays, let's have just make our code a little less fragile, just a little. Then what do we need to do? We need to actually set up the RTC. So equals new context.device.rtc RTC dot divided by prescaler set prescaler to 0. I'm going to need RTC interrupt. Enable event. Do I have to do the enable event and the enable interrupt? I think I do. Tick. Yeah. Well, let's just enable both of them because it can't hurt. Oh, I do think I need to hold on to it. Because I do think I need to clear the I think I need to clear the event because otherwise it'll just count to infinity, basically. RNG dot set enable interrupt RTC interrupt tick none. So I will need to put the RTC, which is going to be an RTC started, and it's going to complain that I haven't imported those, rightly so. What do I need? I need RTC started. No RTC in pack. Is there? Are there multiple RTCs? Is there an RTC 0? RTC 0. There is in fact an RTC 0. Okay. Oh, and it would help if I didn't give it the RNG, but gave it the expected struct pack V. Oh. That'll do it. That'll do it. Did I screw up the RNG? I did, in fact, screw up too many. Did I just? Oh, haha. Okay, how about that? Is that missing RTC? Found struct stopped. Well, that's probably because I didn't start the timer. Enable counter. Okay, which means I also need to have something more like this. Binds equals RTC. I think there's only one RTC. Resources. I don't think this needs to be priority equals 1. Don't think I need. RTC dot get event triggered I guess it probably needs its own copy of the I guess it needs its own copy of the timer. Don't really. Whatever. Keep putting things in the wrong thing. Could not RTC. What are my interrupt names? There's probably a target, and there's probably an interrupt. RTC. Oh, there actually is different interrupts for all of these. Cool. So now we got a ticking timer. Well, hopefully a ticking timer. Let's just in the loop our print line. Well, my timer doesn't seem to be ticking. So my tick is never ticking. What's up with that? I enabled the interrupt and I enabled the event. And by having I'm pretty sure I've used the RTC before. New enable start counter, enable event, get an event triggered, set compare, set counter. What am I forgetting? RTFM should enable this. Why would you not fire an interrupt? This isn't idle, so it shouldn't prevent anything from executing. I thought I had. RTC. Because my NVIC should be enabling my RTC. Like, I shouldn't have to go. This is all. Radio interrupt RTC ticks. Unsaved function, new RTC timer. Because I should have... Because here's my unmask. Because at the end of late resources, it should enable... I don't know why it's not enabling my thing. It's kind of a bummer. Because my timer's getting enabled. No, that's not it. Am I enabling the right events? Enable interrupt. RTC interrupt tick. RTC interrupt tick. What if I... Where is my... I can't get the... What happens if I just penned? I can't pend. So I don't have... I can. Interesting. Where is this? This is target. $73 unused braces. So if I pen the message, it definitely happens, which, you know, is good, but is my counter ticking at all is probably a good question. Well, my RTC isn't ticking at all, which seems like a bummer. Prescaler. Do I need to send it the start event? Although I thought that's what the start is supposed to do. Yeah. Well, this is probably wrong. They should be modifies, not writes. Because otherwise you couldn't enable more than one event at the same time. But that still shouldn't be a problem for me. Software has to explicitly start the LF clock before using the RTC. That's going to be what it is. I didn't enable the low frequency clock, which would make sense why the low frequency clock is not ticking. Expected one argument. What do you... What do you want? You want... Oh. I actually want to say that I had 0 arguments were supplied. What do you want? What argument do you want? Oh, this is the 51. Not any 9160. Oh, this was... external and bypass. I can't remember what mode I wanted. No external, no bypass. Let's try that. It's going to complain that this doesn't exist, but that's going to be in, I guess, clocks, maybe? Used here after move. Does enable XFS Hosk? self. So we're still not ticking, which is interesting. I bet you there's like enable enable cool. I should probably put a big old warning on there that says like, "Hey, you need to have started the low frequency oscillator." Okay, now it's looking like about what I would expect it to. So let's get rid of that. So yeah, that looks about right. About 8,200 in between invocations because it's about a quarter of a second or something like that. I can live with that. Okay, so we have. I also remember there being like a. There's something about like needing to wait for the low frequency clock to stabilize or something like that. There was some like accuracy, terrible accuracy thing where like it was super. Oh, I think it would. Yeah, I think if you didn't wait for the external high frequency oscillator to be started yet, then the low frequency oscillator would be like terrible. But I think it was like even when you were using the external one because it wasn't calibrating right or something like that. I don't remember. It was a long time ago. I probably had this on a stream from like years ago. But I have a clock now and I have relays. So let's. What do I do in relays? From pins. I should set all of these high to start with. Let's just Cool idle. Let's just do a basic okay. Some device to host. Status shelf. There should be shelf status, relay status, shelf status, plant light device message, device to host. I guess this is just status. Let's make a new enum. Oh no. Plant light host message. Okay, I just don't put this anywhere. Plant light. Some host to device. Plant light. Plant light host message. Set relay. And it's going to complain that it doesn't know about any of these types. Host to device message. Plant light host message. Set relay is part of plant light host message. So you're actually host to device message. Host to device. Plant light, which is a plant light host message. Set relay. What are you complaining about? Found RX message, right, because it's an RX message. RX message comes from DSB. RX message is private. Boop, boop, boop. You are not, but I guess your fields are. This struct is private. Oh, it's because it's in the PTX. Cool. And then if we do that, then I need to call relays dot set relay arg. And do I have on or off? This is a really poorly constructed interface. I should really fix this. Use relays. So if I get a relay, cool. Cool. So if I get a relay command, it will do it. So I don't really need to print the now anymore. So in PC modem over here, relay counter, and let's delay 1,000 in between here. host to device, plant light host, message. Set relay. What do you take? You take set relay state. Okay, so it's just going to be what are you unhappy about? Relay counter equals 0. Can't have 1000 U8. Sure. Invalid nonce. What? Why are you getting an invalid nonce? Invalid nonce would mean that I'm not appropriately grabbing the invalid nonce. Why is my nonce invalid? I should probably return some kind of error that's not just a garbage error. Error bad nonce. Invalid nonce. Invalid nonce. Lib. Invalid nonce. PTX cares about invalid nonce. Why would check nonce and update? Probably because my nonce range is going to be like 3000, and that's not. Or it's probably like 10 or something. What do I in my P plant TX main? What am I doing for nonce? Fleet radio 100. 100 ticks is not a lot. 32768. Let's give it at least 1 second to reply. 300 is probably like 10 milliseconds, which is probably just not getting the answer back fast enough. Oops, that's was the wrong one. Now I'm getting invalid nonces. I wonder why I'm getting invalid nonces. I wonder if it's just so behind on packets. Like, if I make this like a lot. That's an interesting thing that you've done. Well, I've managed to make it crash, I think. So what if I do okay, so you should definitely be UTF-8, and I should be doing our print line. And it's going to complain probably that I don't have panic persist features equals UTF-8. Oh. Main 216. Called unwrap on oh hey. So got a little thing going on. Yeah, it was just the relays don't like being switched too fast, so like they actually return an error if you have the wrong value there. But you can see after after 5 seconds, it does the toggling. Yeah, I'm actually pretty happy about that. So now it is responding to relay commands. It's not doing a whole lot back, but you know, I'm pretty happy with that. I've got a little walking LED. Is this okay? It's probably just because this is the speed that this is going at, 250 milliseconds. But yeah, it's like 1 in the morning now, so I'm gonna be done now. So thanks for watching. Good to be back to streaming. Hopefully I'll be doing this more often. At some point I should be going back and explaining more about the pieces that I've done, but I just haven't coded in a couple days. So, well, I haven't coded on this in a couple days, but I'm pretty happy with this. So I hope everyone has a good night, and I'll catch you all next time.